Hi, this is Aiden, and this is my Passion Time Round 2 product. I made a website. My question was, what are the different natural disasters and how do they form? As you can see, I didn't write anything, but so on this website you learn about natural disasters. That's the purpose. So my first natural disaster that I did was a hurricane. As you can see the picture of a hurricane. So a hurricane is a class of extreme hurricane. So it's like, you know what a hurricane is? It's a type of cyclone. So a hurricane is just a really big, strong hurricane. For a tropical cyclone, hitting huge areas of the world for a certain amount of time. Hurricanes form by ocean temperatures reaching 122 degrees Fahrenheit, which is pretty hot. So, or 15 degrees higher than the highest temp recorded, which is, I don't know what the highest temp is, but yeah, 15 degrees higher. And it could also be caused by a large asteroid, volcanic eruption, or very extensive global warming. Hurricanes, so technically it has to do something with heat. Hurricanes used to extend into the stratosphere, which is outside the Earth, but now they're in the lowest sphere. I think that might be the atmosphere. So yeah, that's the first one I did, the hurricane. Second one I did was a tsunami. As you can see, it's big, technically a big wave. So it's right here, tsunamis are huge waves. Tsunamis form by earthquakes and underwater volcano eruptions. So there's underwater volcanoes that explode and make bubbles and stuff. Heat rise to the top and make a huge wave. And when the tsunami forms, water from the shores are sucked up into the tsunami to make it even bigger. And tsunami waves do not resemble normal sea waves because their wavelength is far longer. Rather than appearing as a breaking wave, a tsunami may instead initially resemble a rapidly rising tide. And for this reason, they are often referred to as tidal waves. Tsunamis can be generated when the seafloor abruptly deforms and vertically displaces the overlying water. Tectonic earthquakes are a particular kind of earthquake. Tectonic, tectonic plates form earthquakes. I think it's somewhere near there. That are associated, these right here. Associated with the Earth crustal deformation. When these earthquakes occur beneath the Earth, the water above the deformed areas is displaced from its equilibrium position, so it's moved, technically. More specifically, a tsunami can be generated when thrust faults associated with conversion or destructive plate boundaries move abruptly, so they move a lot. That's what makes them. And resulting in water displacement, so water being all over the place, being moved all over the place. And that is done that is because of the vertical component of movement involved. Movement on normal faults will also cause displacement of the seabed, but the size of the largest of these such events is normally too small to give rise to a significant tsunami. Okay, that was the second one I did. As you can see, I did 7. The third one I did was not third, but cyclone. I did a cyclone. So as you can see a picture, this is not the actual picture of a cyclone, it is radar. So as you can see, the dark red is very dangerous, very big, dangerous and hot or whatever. And red, little less, and then orange, little less, yellow, little less, and then green, pretty, a little, it's just a storm. Sometimes cyclones are hurricanes and typhoons. So there's all these different types of cyclones. Like I said, a hurricane's a cyclone. So hurricanes and typhoons are all kinds of different cyclones. But it depends where they are. That classifies what they're called. And when storms reach wind speeds of 74 miles per hour or 119 kilometers, I think, a tropical cyclone is a hurricane in the Atlantic Ocean or some parts of the Pacific. So it's a tropical cyclone because it's in the Atlantic Ocean and some parts of the Pacific. That's what scientists call tropical areas, I guess. And that's why it's called a hurricane. Other parts of the Pacific Ocean, they are called typhoons. Typhoons. In meteorology, a cyclone is an area of closed circular fluid motion. So you see from meteorology is like space and stuff. So when space is an area of closed, like bunched together circular water, I think, or air or something, motion rotating in the same direction as the Earth. This is usually characterized by inward spiraling winds. So in like the middle, there is spiraling winds, like really big winds and stuff, that rotate counterclockwise in the northern hemisphere and clockwise in the southern hemisphere of the Earth. So it depends which way it's spinning by which hemisphere it is in, which like side of the Earth, top of the Earth or bottom of the Earth. Now, most large-scale cyclonic circulations are centered in areas of low atmospheric pressure. Air mass is separated by a front may differ in temperature or humidity. So, big masses of air, big groups of air, not groups, but sometimes lots of air separated there might be different temperatures and humidity, and strong cold fronts. So like strong cold winds or something that lead all the other stuff typically feature narrow bands of thunderstorms and severe weather. So cyclones typically cause lots of other severe weather. And yeah, so I skipped some of the stuff, but that's that's like science intense stuff. So the next one I'm going to teach you about is volcanic eruptions. As you can see the picture, great dangers, huh? Yeah. And this is a video of Mount St. Helens erupting. It's rare footage, as you can see. Let's skip through this. It's gonna blow soon. It's gonna blow. Oh wait, no, I skipped it. See, look at this. It's like completely blowing up. It's not what all volcanoes look like, but this is an example. As you can see, it's blowing up like crazy. So yeah. Okay, there are 3, so now I'm going to teach you about it. That was a video, as you can see. Yeah. There are 3 different metal types of eruptions. So there's magmatic eruptions, which include depression of gas, decompression of gas within magma that propels it forward, and phreatomagmatic eruptions are another type. And they are driven by the compression of gas within magma. The direct opposite, the complete opposite, the exact opposite of the magmatic eruptions, magmatic activity. The last one is called a phreatic eruption. It's driven by the superheating of steam via contact with magma. Steam comes off the magma when it hits air, and when it gets really, really hot, it is called a phreatic eruption. Okay, volcanic eruptions happen when lava and gas are discharged from a volcanic vent. Volcanic vents are the top of the volcano, as you can see right there. There's top the volcanic eruption. So yeah, that's a volcanic eruption. Tornado. So tornadoes form when warm, wet air and cool, dry air meet. Results in a big spinning tower of air. And yeah, tornadoes violently rotating column of air. Yup. It usually forms in a cumulonimbus cloud, or in rare cases, the bottom of a cumulus cloud. Narrow funnel, or sometimes small, sometimes a bit big. So yeah, I gotta hurry. So, thunderstorms form when warm air rises and cool air sinks. So it's and all ice and water form in the clouds, crash together, they boom together, and they form lightning. And then the sound wave comes off it. It's called thunder. So yeah. Hurricanes are noted. So yeah, hurricanes. I forgot to publish it, but hurricanes 600 miles and rapidly rotating. Yeah, and they typically weaken rapidly over land. So yeah, and yeah, that's it. And on this page, you can get links and some fun facts. I won't tell you it now because I gotta stop. So yeah, I hope you liked it. And I hope you learned a lot. So yeah.